Hello. Are you guys able to hear me now?
Yeah, now you are on.
Okay, cool. So I was just going to explain you guys that what we have learned in the previous class, and we'll be briefly go over it. So first of all, we started with the design patterns and the solid principles ka review. We learned about what solid principles are. We just did a revision of that. Then after that, we learned about the activity diagram and why is this essential for us to make block diagrams, and basically it helps us to know what would be the sequence of steps that we are going to take in a simple system that we are going to design. Then we came into the different types of design patterns that we had: the creational, structural, and behavior. Then we came into the singleton design pattern. Can Divyansh, can you tell me why did we study about singleton design pattern and how does it help?
So singleton pattern actually ensures that we have only single instance.
Okay.
So it reduces complexity and maintainability will be improved
Mm-hmm.
and we have global access.
Correct.
So
And the most important thing, we need the singleton design pattern wherever we want to have only one instance of an object. For example,
yeah.
we don't want to have more than one instance of a database client. We do not want to have more than one databases, and it will create a lot of issues if we have more than one. We would not be able to query the actual DB instead of we would be maintaining multiple copies of that. Correct. So we learned singleton design pattern, that it is a creational design pattern that lets us ensure that we have only a single instance of a class. Then we came into builder design pattern. Can someone else tell me what the builder design pattern was? Why do we need this? Yeah, Riaz, come on, tell me. You guys able to hear me, right? Hello? Yeah, okay, cool. Uh, what happened? Can someone else tell me why did we learn the builder design pattern and how does this help you? Yeah, come on, guys. We have to be quick here. We cannot wait too long. Anyone who knows what a builder design pattern is? Now I'll have to ask people individually, I guess, if you're not saying by yourself. Ajay, were you there in the last class? Ajay, Sangeeta, you guys were there in the last class?
Actually, I was not for the whole class.
Okay. Do you know what the builder design pattern is and why do we use this pattern?
Mm, I think builder we use when we have a lot of parameters for creation of object,
Correct.
and for them like we have a few required parameters. So then and then some optional ones.
Mm-hmm.
So in those scenarios we use builder pattern.
Yeah, right. So in short, whenever we have a very complex uh, class that we need to have multiple parameters over there, and we do not want to pass everything in a constructor. At the time of constructor, we want only the mandatory fields to be passed, and optional fields are up to us whether we want to pass it or not. So if we have to think about that, we would need multiple constructor creations at the time when we are creating that object. We would need multiple construction constructors. So instead of that, we have a builder design pattern which easily lets us to just call this new object of that and then do any optional parameter call like dot age dot build dot address, and we just build it. So in every function dot age or dot address, we still return the actual object that we have used. So this way we can easily use as many parameters as we want by just using a dot parameter over here. Okay. Now, after that, we learned about the factory design pattern. And factory design pattern, say we were able to understand that this is again a creational design pattern which helps us to create objects of any data type. And how does it help? If we need to create multiple new objects of that, of a class, and we need some kind of modifications in that. So in case we just need in case we use a new keyword to create an object of any object class, we would require to change that parameter everywhere. So instead, we say that we'll have a factory class which will maintain the objects, what all parameters we need for this particular class in one place, so that if there is any kind of changes happening, we just need to make change at one place, and everything else would be sorted from there. Okay, then we learned about the strategy design pattern. And we took an example of the laptop, where laptop is a base class, and we were implementing laptop in MacBook, Dell, and Asus. And what we learned over here was key the strategy design pattern says if we have a common attribute like a keyboard or a mouse in the laptop, but we have some modifications in MacBook like a high performance keyboard or high performance mouse in MacBook or Asus, there would be a lot of duplicate code that we need to write in MacBook and Asus. So instead of that, what we do is we delegate that function into a different interface, and that would be imported in each of the child classes as well as in the parent as a form of interface. And at the time of object creation, we would just pass on which kind of an object or which kind of keyboard, which kind of mouse do we need in MacBook or Dell, and will be sorted from there. So we learned that we would not require to create multiple uh, we would not need to change anything in the MacBook, Asus, or Dell class if we just have one interface which will be uh, having interface keyboard or interface mouse or interface screen. Okay, so this way we can have any different kind of keyboard or mouse, even if there is change in the keyboard or mouse in future. We just need to import it, and while at the time of object creation, we need to pass on the object. After that, we learned about how do we uh, take the requirements and do an actual design of a problem. We learned about the parking lot design, and we did some requirement gathering, interface design, and finally we were able to make the what do we say, the end-to-end flow diagram of that. And today we'll be learning about how do we design snakes and ladder. Okay, so without taking any break, we will just jump onto this. Cool. So, guys, I've already written the functional requirements here. So, can you guys tell me, apart from uh, this, what all things? Acha, tell me, what do you think about, uh, like, what all requirements or what all things are you able to think when I'll tell you that you are going to design a snakes and ladder game? Quickly tell me. I'll just write it down over here.
Man, are you sharing your screen?
Yeah, I am sharing. Are you not able to see my screen?
Yeah, it is not visible.
Okay, man. Okay, I was sharing my screen, no problem. Are you guys able to see my screen now?
Yeah.
Okay, cool. ठीक है, my bad, man. I did not know I'm not sharing my screen. ठीक है. Uh, Now let's try to design a snakes and ladder game. So if you see this picture, what do you think if you are actually told to design an application, let's say in Google Play Store or somewhere, you have to create an application snakes and ladder. What can you think of? How would you start? What can you think of, like if you immediately look at snakes and ladder, what do you think? What do you need immediately over here? Tell me. Do you think you need a board at least at the very start?
Yeah, first we can define components like board, how
We would
do we are player representation, I guess, dice,
we would need players. We
yeah,
would need
dice.
What else?
Snakes and ladders.
We would need a snake. What else? A ladder.
Yeah.
And anything else?
Game logic will also be there. Some game logic.
Correct. We would also have a game logic that this particular game will take care of all the boards and everything, right?
Rules will be there.
Rows,
Yeah.
cells.
Yeah.
Rows, you mean individual cells, right? This one.
Yeah.
So we can say a cell or a board ka entity. It
Yeah.
could
Yeah. Board का entity is
could either be a ladder over here which is going up, or it could be a snake which is biting and dropping you down. So cell or a board entity in short. Cool. Anything else that you guys are able to think of over here? So I'll just give you the functional requirements that we need to create a snakes and ladder game, and we need to take the input n from the user. So we do not know if it is going to be of size 6 or it could be of size 10. So for that, we are just taking that will take n as the input from the user. Now if we take the n input, the board should be of size n cross n. There would be n number of snakes and n number of ladders placed randomly in the board. Cool. We will figure this out later. And each snake will have head at some number and tail at some smaller number. Okay. So we are told that snake will not bite a person at some, let's say, number 23, and it will not take you to 40. It will always drop you down somewhere. And again, ladder will be at a point, some number where end position is larger. So always the ladder will take you up and it will never bring you down. And there can be multiple players in the game. So is this requirement clear to everyone? Or is there any doubt that you guys have right now? Anyone? If you guys don't have any doubts, just give me a +1 in the chat. Okay, cool. Okay. Now coming to the rules. Okay. So we already know that board number will start from 1 and it will go up to n cross n, basically uh, n square. The players will take their move one by one. The game will have a six diced number, and it will have 1 to 6 on that. It will give a random number in each rolling. Each player has a piece which is initially kept outside the board from 0. Each player rolls a dice when the turn comes, and based on the dice value, player moves their position forward. So if it is at position 7 and 4 comes, it will move to position 11. Player wins if he reaches the last cell of the board. Then, whenever a player ends up at a cell with the head of the snake, the player should go down the cell that has the tail of that snake. So it is obvious. Again, with the ladder, if it is at some position X, it will take you to position Y. We'll go there. Game should continue till there are two players still playing to win. Okay, we have to like determine if there are, like, say, five players. We'll have to tell who is the first, second, third, and then fourth. Fifth we don't care because he'll be the last person to win. After the dice roll, if a piece is supposed to move outside position 100, it does not move. Snakes and ladder do not create a cycle. So I hope this is also clear to everyone, the general rules of a snakes and ladder game. Cool. Now coming to what we have already defined here, we will just have some more detailed representation of interfaces and classes. So we already know we need a board. What will a board have? It will have a size, right? Let's say this is a board. How many number of cells are there? This particular size will tell you. Let's say, yeah, size will be equals to whatever is the n input given by the user, and it would be n cross n. Then we have a map of integer. So basically each cell that we have, we are putting it in a map and mapping it using an integer, and it could be any board entity. It could be a ladder, it could be a snake, or what else? It could be nothing. So for that, we'll just say null. It will just be an empty cell where a person could go. Okay. And what will a dice do? It will roll the dice. It will give you a number between 1 to 6. The players will have a username and the position where it is actually at right now. The board entity, what will our board entity have? So it's, let's say if it is a ladder, it will have some starting value start and an ending value. Again, a snake will have a starting value and an ending value. So we have written it already here. We have written the ladder. And what does a game have? So we need to have everything placed in a particular place, right? So for that case, we have taken the game, and game will contain, first thing is the dice count. So in general, we play with one dice, but somehow in future, let's say people are playing with two dices, or some people actually play with two dices. They roll two dices, and whatever is the sum, they just go those many steps up. So for simplicity, we'll consider the dice count as one, but we will design it in such a way that it can also be extended to two. Dimension is something which the user will give us. The n board we are already taking from this board class. We will compose it inside the game. So I'll tell you how would this board be used inside the game class. Size, we already know it is n cross n. Players, this would be a list of players, and then winners will again be a list of players who have completed their game. So I hope this is all clear to you guys. Anyone having any doubt till now? Tell me. Anyone? Okay, so I'm assuming everyone is clear till now. Cool. So what I'm thinking is we can just directly jump into the coding part of how we would. Are you guys able to see my screen, right?
Yeah, it is visible.
What are you able to see?
IntelliJ.
Okay, so we'll just create a package, snakes and ladder. And first of all, what did we think we are going to decide? We'll have entities inside it, right? Different kind of board, the game, and those things. So we'll define entities inside it. What is the first entity that you guys are able to think of?
Board.
So let's create this board. What else did we have? We had a board entity, correct? But we do not want board entity to be a normal class. We would want a board entity which will be imported, like extended by the snakes and the ladders. So we'll have this as an abstract class. We can also take it as an interface, but here we are taking it as an abstract class so that we can have a few common functions defined over here. Okay. Then what else did we need? Tell me.
Dice.
Dice. Yeah, we need a dice, but what does a dice do here? It's not an entity. We would
Yeah.
some kind of service thing which will be
So
defined.
we will use some kind of like method random or something like
Correct.
that.
So it will not
Function
be
will do, yeah.
correct. That's right. So for now, we'll just say we have a class snake which is extending what? Board end.
Board.
That's right. What does a board have? What did we say board entity would have? It would have a start point and it would have an end point, starting and ending values. What else do you think we would need over here? We would need a constructor and getter setter, right? So for now, I'll just create a constructor with these two values. This constructor is created. What else do we need? The getter and setter for
So there
start.
we can make start and end as private.
Correct. We can make this as private. And we would just be using it as it is. So we have one related problem. Why does we have a problem? So we'll just call the snake kabi constructor over here. What else do you think we would need in a board entity? We have start, we have end, we have the set. I think we would need a function to just say that we are either at the snake or we are either at the
Type, yeah.
correct. So we'll have just abstract class which would say public abstract, and it will not return anything, and we would say we would use this get string in our snake and ladder classes, which would be overwritten when we write it in snake class. Get string will say ki we are at snake or we are at something, right? We are at the ladder, that kind of thing. And we would also say we would take it. First of all, we'll just use the string for now. Now we would create one more entity, which is ladder, which will extend our board entity. Now, since we have created, implement the methods, get string. What else do we need? We need a constructor. So this is also created. Get string may what would we return? Let's say we want to just say, or instead of what I'm thinking is, instead of just uh, printing the value here, we can return the value instead, and we would use it in the place where we are calling this. So instead of having a void type, we would have a string type. The ladder has this, the snake would also have the same thing. We have this, we have a ladder. So what would this return? We are at ladder, and what I'm thinking is, while doing the print of the board, right, we would say that this is the ladder at position this, and where does it actually go? So for that, I'm not going to write entire ladder. L is enough, right? And what else can we do here? What is the end point of that ladder? So we know the
Yeah,
starting point, and we will just
and
print the point as well. So what would be the end point? It would be this dot get end
and
value.
getter, yeah.
We would just return this string from here, and the same thing we would need in our snake class. Get string, it will return snake, and this is the end value of that. Now I'm thinking, let's say so this is required at the time of printing the board. Now let's go to the board. What do you think we need it in the board? Let's come here. Board will have a size and a map of board entities. So let's define that. What does a board have? It has int size and a hash map of integer with board entity, and we will name it as cells for now. So now whenever the constructor of the board class would be called, what do you think we would need over here? We would need some kind of dimension, right?
Well,
So that we know that this is the size. So our size would be, in that case, equals to dimension into dimension. This is clear. And when we create the object of our board class, we will say create a new hash map, and we would pass on integer comma board entity. So our hash map is also created. Now what do we have right now? Cell is empty, completely empty. Do you see that? We have not defined key which cell is having what, and we also need to have n number of snakes and n number of ladders in that board. So what are we going to do now? Create n snakes and n ladders in the board. How are we going to do it? We are going to iterate. Index will be starting from 0. Let's go from index which will be less than dimension. So we'll do n number of dimension is our n, right? You all guys know that will be less than our dimension, and will increment our index. Now what are we going to do is, first of all, we need to have a snake. Later we'll add a ladder at position uh, some value s start. Okay, add a ladder at position start. So do you guys see we would need some random algorithm over here to be written, which would help us to generate the snake from position start to position end. This is clear, right? So what do we have here? We would have a minimum value. We cannot have a ladder or snake at position 0 or position 1. That's obvious, I guess, right? We can start from 2. And what would be the maximum value where we can place a snake and a ladder? It would be size minus 1, because we cannot have a snake at position 100, which is the winning point. I hope this is clear to you. Correct?
Yes.
Now tell me, if we want to have a random value of, let's say, start, how can we do that? We need some random function, right? So we'll use the math.random, and what we can do here is we can have the range defined. What would be our range? It would be maximum value minus the minimum value, and we can have +1 to have the entire range covered. So maximum is, let's say, if we have the dimension as 10, what is our maximum, which is 99. The minimum is 2. So in between, the range is going to be 99 minus 2 plus 1, which is 98. So mat.random returns as any value between 0 and 1. We would multiply it with that range, and then we will place that cell. So let's say we got a value 0. 0 into some value is going to be 0, but we cannot have start at position 0 of any snake. So for that, we would increment it with minimum, and we would typecast it into int. We'll take the floor of that just in case. So this is clear, right? We have the starting value over here now. And what else do we need? We would also need the ending value of that snake. It starts at position start, but end is not clear to me. Now, for that, our maximum will now be before the start. Let's say our starting value is 40. The snake ending point cannot be after 40. So for that, I am going to change our maximum value to start minus 1, just to have the ending value of that tail before the start value. And now we would do the same thing. We would typecast it. We take math.floor and do a random value here into our mx minus mn plus 1 plus the minimum value. So this way we get the starting and ending position of our snake. Now, what else do you think we would need to check? So this, let's say we have a starting point 40. Do you think we would have to check if that place is already occupied by one snake or something? Is snake or ladder present? If it is present, we won't make any kind of snake in that place. If it is present, if it is not present, then we would do some kind of thing. And what would we pass here? We would pass the starting value. If this is not the case, then we would add the snake entity at the position start. I hope this is clear to you. Now we have to write the function if that particular snake is present over there or not. And this is only required at the time of our board construction. So we can have a private method here. Is private, what will this return? It will return a Boolean value. Is snake or ladder present here? So we'll just have this name, snake or ladder. And what do we need here? We'll need an index. Now, how are we populating our board? We are populating our board with the cells. So what do we do here? We'll just return if this dot cells dot contains key index, or if our index inside the cell is containing something, then what do we return? We'll return true, otherwise we would return false from there. Now if this thing is there, then we don't need to add it. If there is no snake or ladder, what would we do here? We can add a snake object inside it. So what do? We would add snake, or better, we would add a entity instead of that. So for that, we can have a private function which does not return anything, and entity, what does this take? It will take some index, and what else? It will take a board entity. Now what do we do here? We have already the cells. We'll just put this entity at this index, and we would return from here. So we do not need to return, so we'll just complete this here. We don't need this. Cool. Okay. I think everyone is clear until now, till this point. If there is no snake or ladder, we would add an entity. Where? So we'll just call this function add entity. And what do we pass here? We'll pass an index and an entity. So what do we need? We need a snake to be created. What's going to be the start and end? It would be the start value and the end value. So this way we would add an entity at position index. Now, if our starting position was 40, so, and let's say ending position is 29. So now a snake is created at 40, which is having a tail at 29. And we have added that entity where our cells is keeping a track of all the entities that we are adding. Now we need to do the same logic for the ladder as well. Correct. So what do we do here? We'll have minimum as 2. We have maximum as this dot cells minus 1. And now we again need to have a start and end. But the thing is, the ladder has to be yeah, somebody is saying something.
So this code looks very similar to our code. Can we create a function here?
Sorry.
This code looks very similar to our code, right?
Yeah,
As we
this
have created.
we have written, right?
Yeah. So we can create a function or not.
Yeah, we definitely can create a function over here. What does this take? It takes a max and min and return us the starting value. We can definitely use this logic over here. But for simplicity, for now, I'm just going to have this thing, this dot cells dot size. We have our max and min. So let me have this function also here. Private integer random value. What does this take? It takes the max value and it takes the min value. And inside this, it will do some logic, which we have already written here. Yeah, this is a good point, which you have said. So starting will be the floor of math.random, max minus min. We have a start value. And here, okay, we are returning two things over here. So, okay, we would just need to return our start value from here. We don't need anything else. Start. Random value we would call from here. So our start would be equals to random value, and we pass mx and mn. So this way we know what is our start value. Same thing for our ending value. What do we pass? Random value, mx and mn. Since we have already updated our mx to start minus 1, it will return us some random value which will be between mx and mn. So this is a good thing which you have mentioned. Now we again have max and min. This dot cells dot, okay, this dot size, yeah. We have our max and min here. Now again we would use to, okay, so this time our ending value of the ladder would be up. So for that we would use the function ending would be equals to the random value of max and min, and max would be updated to what? N minus 1. Correct. What would be our start value? Start would be random value between mx and mn. So this way we get a starting and an ending value. Now we would again check if there is snake or ladder at the position start. If there is something, we would skip it. If there is nothing, we would add an entity at the, instead of index, we have the start value. ठीक है. We would add at the position start, and we would call a new ladder object. For now, I'm just telling you that instead of calling this new ladder, we can have a factory method also. So we can say that we'll create a new package instead of snake and ladder dot factory. And what does this factory have? It will have a board entity factory. So this will return us either the snake or the ladder, depending upon the choices that we pass over here. So for now, let's just create a ladder here. Later we will do some refactoring. So now we have created a ladder at the position start, and this way, after 10 iterations or after dimension number of iterations, we would have n number of ladders, and we would have at max n number of snakes at their positions. Okay, so our constructor for board is done. What do we need? What else do we need? So this is just the start, right? And what other entity do you think we would need? First of all, I can think that we need a service to get us the dice service, right? It won't be a normal entity class, it would be a dice service. And we don't want to create an object of dice service, so what do we have? We have it defined as static method. Right. Roll dice. What does this take? It will take the number of dice counts that we public static int roll dice. It will take the total number of dice count. For example, we would be testing it with one dice, but we can also have more than one dice count if we want it in future. So now, what would be the random values that we again need in between? It would be the minimum values as 1. What would be the max value of a dice? 6, right? And we would multiply it with the dice count. I hope this is clear to everyone, right? Int value after rolling, what do we get? So what do we write? We would again write that same function, just copying it from the previous board class. I think we can have this random value defined as a service also, so that we can use it everywhere. But for now, for simplicity, we would just use it over here, and it would return us the random value of in between max and min value. So this is clear to everyone, I hope, right? So we would get this roll dice, and roll dice will return us the value. What else do you think we would need in an entity? We would need one game class, right? And what else did we have? We would need a player. That is very important, that we have not written till now. So let's write a player entity before that. We have a player class. What does a player class have? Tell me. We defined it here, right? A username and a position. Everyone clear till now, right? I hope nobody is getting, everyone is understanding till now what is happening. So what does a player have? It will have a username and it will have a position. So for this, we will just create a constructor. And what do we need? We would need only the username, because by default, the position would be equals to 0 every time. So we just only need the player ka username. And now We would also need to create getters and setters for username and position. So we just create getters and setters so that we can use it in other places where we want. So our player is also sorted. What else do you think we would need? We have the game class, which is very important. So now let's see what the game have. Game is having a dice count, a dimension, a board, a size, players, and winners. So let's create those things. Player has a list of players. So let's define a queue of player, which will be players who are playing. We would have a queue of players. We would have a queue of player who are winners, which we would keep track of, and we would have a dice count, we would have a dimension, we have a size, the total size of the board, and we also need one board. So let's create a board as well. Board. Now time to create a constructor for this. So we would create a constructor with all the fields over here, and we don't need to pass the players initially. The players would be an empty list, linked list, which we would add at the time of object creation. Okay, so the winners and the players will be an empty linked list. We have a dimension, we have a size also we do not need. Size would be equals to what? Dimension into dimension. What else? A board. Do we need to pass on a board here, or we can create a object of that here itself? We can create object. What else? What does this need? A dimension. That's it. So our constructor for the game is created. Now, what does the game? So this is a driver kind of a game, right? Of a class. How would our actual person say that do some operation so that our game is starting? Tell me, guys, what do you think we would need? We would need a function, right, to, let's say, launch a game or start the game, correct? Which would be called from the driver class. Public void launch game. What does this need? We do not need, because we have already created the constructor of dice count and dimension, and we already have the values. So our object would be created, and we would just call the launch game from there. So what was the logic? Let's go back the program. What was the rule that they have defined? Key, there should be at least 2 players in the game. So let's say there are 5 people playing in the game. The game should continue until 2 players are still in the game. So let's handle that condition for now. So if we launch the game, it will run unless and until the players dot size is greater than 1. If there is more than 1 people, the game will continue. What will happen? So let's say we say that the game has started, the launch has started. What would happen at that time? Okay, there are list of 5 people, let's say 1, 2, 3, and 4 and 5. What would happen? The first player needs to roll the dice and move to some position, isn't it? Do you get that? What would happen here? Pick the player whose chance is now. Then what will he do? Roll the dice. What else does he need to do? Move to position after rolling dice. We need 3 things to be done over here. So how do we get the player who is currently playing? So we can just do the players is a queue, right? So we can just do a poll on that. So we have a player, we would say current player, which that would be equals to what? Players dot poll. It will return me the current player that we have. So once we get that, let's write some print statements that who is the current player. Current player is, we would write its username. Current player dot username. That is fine, I guess. This is fine. We can also write its position, but that so yeah, let's write its position as well. With position, current player dot get position. We cannot use username directly, so we need get username here. Cool. So once we know who is the current player, who is the with the position, we would roll the dice. How do we roll the dice? We would call some function of rolling the dice and moving the player. So here we can write a function which would be move player. And what do we pass here? We would pass on the current player over here. Now we need to define the function which is move player. So let's write a private void move player. It will take a player here. Yeah, we have the player defined. Now move player we have written. What is the problem here? What we would do, why are we getting a problem here?
You wrote the method inside the method.
Oh, okay, I wrote it inside. Sorry, my bad. ठीक है. I think this is fine now. Move player. We have. Did I write it outside the class?
Delete one semicolon. That curly brace. Not that. I'm like inside. Launch.
I think this is fine now. So we have move player. What does the player do after coming here? The player will roll a dice, right? So what do we get from rolling the dice? The value. Dice value. It would be equals to dice service dot roll dice. What do we pass on over here? The dice count. How many dices are we playing with? We need to pass it from here. The dice count. We would just pass on the dice count. If it is 1, we would get a value from 1 to 6. And after getting the dice count, what do we have? The final position. It would be equals to player dot get current position plus the dice value. Now think of what all possibilities are going to be there. First of all, let's say the player is at position number 99. He gets a value 5 and the ending position is at 100. Can he move ahead? Current position is 99, size is 100, and he gets, let's say, 5. Can he move? What should be done here? You guys have played Snakes and Ladder, right? Tell me what should be done here.
Only one is allowed.
Okay, only one is allowed. So
Pass on to next player.
Yeah.
correct. We don't need to do anything. If our final position is greater than the size of the board, what do? We'll just say we cannot do it. Or rather, we'll do it like this. If it is less than or equals to the size, what would we do? We would move to that position. We would need to update the position of that player. So for now, I'll just write one print statement that current, not this thing, moving to final position. And now we need to update the position of the player as well. So player dot set position, it would be equal to final position because it is within the range. If it is not within the range, also no, we forgot one thing. Also we need to check if that final position has a snake or a ladder. We move to the last position after that, correct? Tell me, you guys able to hear me? Board dot, we need to define the board dot is snake and ladder as public. We would use that over here inside the game. If the board contains a snake or a ladder, we won't stay at the final position by moving the dice. We would move to the actual end location that we need to do. So we would print something, but what do we print? We encountered a snake or we encountered a ladder. How would we know this? Tell me. We need a function again in the board entity for that.
We have
Let's-
get string, right?
Sorry?
We have a get string.
We have a get string, but yeah, that does not tell us exactly key the string over there is only required at the time of board ka printing. It is not going to return us key we encountered a snake or we encountered something else. So for that, we will have one more function. We'll have a public abstract string encountered message. So if it is a snake, we would just write implement methods. What do we return here? Oops, we encountered a snake. Similarly, for the ladder, we would implement that method which would return as woohoo, we got a ladder. Sounds fine, right? We can override that method. Now in the game class, we can just straight away call this function. What? We need the entity, right? So board dot, we would say cells dot, what is the index? Get index dot encountered message. Index is what? My final position. So this way we do not need to worry if it is a snake or a ladder. It is by default automatically handling what encounter message we need to write. I hope this is clear to everyone, right?
We should remove that not condition from if, right?
Sorry?
On line 55, we have if not of board dot is snake or ladder. So if it's not, then it shouldn't go inside, right?
Yeah, if it is a snake or ladder, then we come into this place. Correct, that's right. So we would print the statement if we have encountered a snake or a ladder. Now, what would be the end location? So my end position after the encounter of snake or ladder would be cells dot get final position. So I'll just do board dot cells dot get position dot get end. This is clear, right? So if we are using it 2 times, let's just create an object of this. Board entity, let's write it as entity is equals to this entity. Now we need to call entity dot encountered message or entity dot get end. So if it is a snake, it will put you at some lower location. If it is some ladder, it will put you some at some higher position. So end position is a redundant thing. Let's just update our final position with this thing. So now we have our final position wherever we want it to go. If it is a snake, we go there. If it is not a snake, we go to final position, what we were getting after the dice count. If not, what do? We were at position something else, right? We'll just write some print statement. So let's just write println. Oops, you crossed the board, and then please try again later. So this message is enough. We are already at the value. So if it is crossing, we don't need to do anything, and if it is not, we move the player. So I think everyone is with me until now. Tell me, guys, anyone having any doubts till now? Why did we do this? Why did we do that? Or something. One more thing, we have to have a public method to add the players in the queue. So what do we pass on over here? We would say this dot players dot add, and we would add a player over here. Similarly, we add the players. We can add a constructor for this. We can add a getter and setter for everything, for winner and players, I guess. Not for everything, but yeah, for the size dimension, this is clear. Now we would launch the game. And yeah, correct. We forgot one thing. Tell me, what did we forget?
Current player should again be added to the end of queue.
Correct. If the player has already won the game, then remove him from the players queue and move to the winners queue, isn't it? We have moved the player, so we know what is the current position of that player. So what do we do here? If current player dot get position is equals to my size of that board, we would say system dot out dot println player current player dot get username 1. Okay, now we have already removed him from the queue, so we would add him to the winners queue. Winners dot add the current player. We do not need to add it back to the queue. Otherwise, if the player has not won, what do? We would add him again back to the players queue. Players dot add what? Current player. Getting me? What else are we going to do in this class? We have moved the player. We have add player. Now I think we would need one driver class. So let's just create a driver class to call the function of launch game from there. So we'll have public static void main. We'll have string as args. And what do we do here? We create an object of game. What do we pass? We need two parameters, isn't it? The dice count. So let's say dice count is equals to 1 for now, and the dimension is going to be 10, let's say. So what do we pass here? It needs a dice count and a dimension. So let's pass on the dice count and the dimension. We have game created. Now we need to create players and add to the game. So what do? Player, let's say player 1, I'll just create object of that. Let's say its name is A, or let's say his name is Ajay. Player 2 is equals to new player, his name is Divyansh. Who else is there? Let's say his name is Raj. So I have created 3 players. Now what do? I have the game object created, so I'll just call game.add player 1. I would add player 2, and then after that I will add game.add player, and I'll add player 3 over here. After I've added all those players, I'll do game.launch game from here. So do you guys see how I have written the code so that I can also test it from here? Now let's see what all things are we missing. So there's something missing in the game. I can see some error over here. What is the error? There's some error. Let's see. Expected semicolon. Okay, cool. I have added the semicolon. Now we have a factory method for entity. Okay, we needed an entity. Now what else do we need? We need an enum for that. So we'll create an enum to tell if it is a snake or a ladder, right? So entity enum, we will have a snake and we will have a ladder. Now inside the entity factory, we would again have a static class of what? Create entity. What does this take? It takes an entity enum, and we'll just name it as entity. So we'll have a switch case. Let's say switch entity. What would be my case 1? Case, let's say we'll take the case snake. So here, if it is snake, what do we return? We will return an object of snake. What does this take? It takes the starting and the ending value. So along with this, I would also need start, and I would also need the ending value for that. Now it returns an entity. So let's return the type of it as pod entity. This is clear, okay? Now we also have a case for ladder, and it returns me a new ladder. It takes the start and the end. Why am I writing this factory? Everyone is clear, right? Why? Because if there is any change in the parameters of snake or the ladder, what would we do? Null. In case there is some random value, we would return null from there. So we would call this function of entity create from the entity factory. It would pass on the snake or the ladder, and we would be sorted from there. Okay. Now tell me, guys, what have I forgotten something, or are we done? We are still on time. We have good amount of time, so we can discuss now. If anyone having any problem till now, and let's see if we have figured out all the test cases or not, or all the requirements that we gathered initially. So what was our requirement? We wanted to create a snake and ladder game. The game should take an input n from the user. The game should have a board of size n cross n. There would be n snakes, which we figured it out and we have written it. Each snake will have head and tail. We have considered that case. The ladder will have a starting point and an ending point. We have covered that case. There can be multiple players in that game. So you guys see, I have covered all the functional requirements in this. Now it's only the time to have some more modifications. I mean, we can have something like a print board. Okay, so how does the board even look? We don't even know that. So for that, let's have a class public void print board. What does this take? It won't take, I guess it won't take anything. Yeah, it won't take anything. So how would we print our board? It should be, let's say if the value is 10, we would traverse from left to right, and then starting from 1 at the very right side bottom, then we'll have 2, 3, 4, 5. In that way, we'll have 100 at the top side and at the leftmost side. So what I'm thinking is, we can have a function public void print board. So it will start from the dimension, or better to have some size defined over here, so that we start from that value and we come total size tak. So we'll start from the topmost position. Index will be equals to size minus 1. So we will not print 100 because that is the end position. We will go up to, index will go up to the value 1, and we will subtract our value every time. Now, how would our board look? It could have either some value, it could have some snake or some ladder. We would have to show it somehow, right? So let's say I just add out.print. We won't do print ln, we would do print index. So what would be printed here? I would print 99, but I also need to think or see if that 99 is having a snake or a ladder or not. So for that, I will just have one condition: if is snake or ladder, and what do I pass? I pass an index. If it is a snake or ladder, I can use the method that I wrote in the board entity for getString for printing our board value, isn't it? To get this, what we decided earlier. So let's come back to our board. If it is a snake or a ladder, what do? I would say system.out out.print. I will add some spaces, and let's say I add what I have board entity. So this dot board entity, one second. Okay, this dot cells dot this dot cells dot index, and I would print the string from it. So this way I would be getting a print value of if it is snake or a ladder from there. I have already printed this. Now what else do I need to do? Every time after some dimension, I know what is the dimension of this. So let's also have that inside this. So after every dimension, I need to go to the next line, right? So it will be from 99 to 90, then 90 to 81, then 80 to 71, that way. So we'll have end line printed after every dimension value. So what would I do? If my index mod my dimension is equals to 0, what would I do? I'll print a next line, system.out.println. That's it. So this way I would print my index value, my cell value, but I'm just thinking, just to format it in a better way, I would need to have some more spaces over here. Okay, ठीक है. We have this also clear. Now we will again have one print ln line after we have printed our board. Cool. So board would be created, board would be printed. Where do we print this board from? When our board dimension when our board has been created, we have added snakes and ladder to it. We would create print board from here. What do we pass? We would pass the size and the dimension from here. Okay. I hope everyone got me till now. Anyone having any doubt till now? Just tell me. We would add an entity, we would add a snake or a ladder, and now we have a move player function, we have an add player function. Okay, but I'm thinking, how would we say that the person has to roll the dice? We have not figured that thing till now, isn't it? So let's say the person 1 played the game. How would person 2 roll the dice, or we have to figure out that as well. So when we wrote this launch game, it will iteratively run several times and we won't be able to see what is happening as well. So for that, let's have a scanner to take the input from the user, just so that we are able to know what is happening. So can ch will be equals to c dot next dot caret 0. Okay, we will take input from the user to roll the dice, and we can have one print statement as well here. System dot out dot println press any key to roll the dice. Current player is this, and then press any key to roll the dice. This is clear, right? Now let's try to run our code and figure out if we have missed anything in our driver class or not. So let's try to run this code. If there is any error, we will fix that thing. Okay. So what we did is, okay, it is returning me some random value. Okay, let's see this thing. We are printing 99, we are printing 98, we printed 97, but before that we printed the snake ka value as well. So let's just change the print board function from there. Is some print board may, instead of doing this, we did a print of the snake value, but we need to do it before this. Okay, and over here as well, let's have a few spaces. I just want to make it format a bit more in a better way. So let's see if this thing works properly or not. So we have 99, we have 98, we have 97, 96, we have 94, but before that we added a lot of space. So we printed 95, we added a lot of empty spaces here. So let's remove this thing. Okay, let's remove this space, and let's just remove a bit of this as well. So this 95 वाला pointer के बाद I had to print snake कि ठीक है 95 पे there is a snake which is taking me to position 56. This everyone is clear, right? कि at position 95 it is taking me to position 56. Then there's 94, 93, 92, 91, 90. Then there is at position 89 I have a snake which is taking me to 46. Similarly, I have a position 58 where the ladder is taking me to 58, 87. Now it is saying that current player is Ajay with a position 0. Press any key to roll the dice. So let me press any key. Now what it is saying, moving to 1, the current player is Divyansh. It is moving with a position 0. So I have to format it a slightly better way so that we just know key what is happening. So now the next player is Divyansh. Let's again press some key. It is also moving to 1. Now the position is Raj. The next player is Raj. Let's see where does he go. He's also moving to 1, moving to 2 position. Let me see if I've made some mistake in the dice wala class or not. And let us also format this thing a bit. Now I will also add one method to print the positions of the player over here. After every turn, we will just print the positions where the players are. So we'll have a private void print players. It will not take anything. We'll just iterate one by one into the players, and we would print the name, print ln. So it would be player dot get username. Then we would add is at the position player dot get position. This way we would know every time after each turn what is happening. So where would we call this function from? We would call this function from after the movement of the players have been done. So we'll just print the players from here. Or better to have print players in the start. At the very start. Let's have it at the very start. So it will tell me where the players are and where are the players. Now moving to, let's have a new line after this. Moving to final position. We have the final position. Okay, we are not using this dice value, it seems somehow. So why are we not using this dice value? Okay, we were missing this thing. Okay, now let's go to the roll dice as well, and we will print the statement of what the value has been returned from here. Rolled dice with a value. So this will return me what is the value of the dice after it has been rolled. Now going back over here, we saw that the dice value is not getting used. Why is it not getting used? Okay, I wrote dice count here, so forgive me guys, it is dice value. Now let us try running the code again. We have made some format changes, and hopefully we are seeing some better format, but it's not that good as well. But it is saying me that there is Divyansh and there is Raj, and the current player is Ajay. Okay, is it not printing Ajay before? It should have printed, right? Let's just see what happens here. Press any key to roll. So what we got, roll dice with the value 4, and moving to 4, Raj is at position 0, Ajay is at position 4, but the current player Divyansh is not getting printed for some reason. We will see why is it not getting printed. But now this is the chance of Divyansh.
We have already polled the current player, so that's why.
Okay, I got it. ठीक है. That is the reason. ठीक है. Anyways, we have Ajay at 4, we have Divyansh at position 3. Now the current player is Raj. We would press something. We have so we are seeing that everyone is moving somehow at some position, and after a point of time someone will be reaching the position 100. So what happened? Player Divyansh won here. So let me just see who won the first. So Ajay won over here and Divyansh won the second. So basically it means that Raj was stuck at position 95, Ajay won at the first, then Divyansh won, then the Raj. We had 3 people, so it worked as we expected. Okay. Now tell me guys, if anyone has any doubt anywhere to understand ki why did we choose this, why did we choose that, we can have this print player wala logic which could be improved. So before polling this player, I would print the players where they are currently at. Okay, now let's see this again. So what does it say? Ajay is at 0, Divyansh 0, Raj 0. Current player is Ajay with a position 0. We pressed 2. What happened? We got 2. So you can see this, right? Ki 2 pe there's a ladder and it is moving you to position number 3. So we got a message, woohoo, we got a ladder. Now Divyansh is at position 0. Current position is Divyansh is at 0. Now it's his turn to play. So let's say I pressed some key. Ajay is also at 3. Divyansh is also at 3 because he got a value 3. Now the next person, Raj, got a value 5. So he moved to 5. So similarly, it will, as I showed you, it will run unless only one player is left in the queue. Okay. So this is how we would be, and it is taking a lot of time, but okay, let's just end this here. It took a lot of time. Anyways, it worked, right? So does not matter. We can format the code a bit more. We have written the fully functional launch game code. Anyone having any doubt? Now it's your time to say. Did you guys understand what I explained right now?
Yes, sir.
Yeah. Now, tell me, like, did you guys see ki we are having any problems while understanding, or why did I write this code? I should have written it in some other way, or you guys felt ki this is pretty difficult to understand, or anything like that? Tell me. I created a factory method, but I'm not using it yet. So let's just also use this entity factory. Where was I creating that new snake, right? I was doing this new wala object creation here. So instead, what am I going to do? I would be using my entity factory dot create entity. What am I going to pass? I'm going to pass enum dot snake with my start and my end value. So this is how our new object creation would be handled. This is clear, right? Now, so same thing would be done for my ladder as well. So I'll create entity factory dot create entity. What do I need? Entity enum dot ladder, and I'll pass my starting value and my ending value. Now my object of ladder would be created at the position start. Now we have used most of the functions. We are using this enum as well. We are using this entity factory ka create entity. We can also use one more factory for creating the player, but we have only one kind of player. So for now we would not be using it, but in future, let's say there's a different type of player also coming in. Let's say a premium player who is paying some amount to your application, who will have some more facilities, will have some more things. That time we will create an interface of the player, which would be implemented by a normal player and a high-tech player, or a paid player, or premium player, something like that. Okay, so that time we would be able to implement the functions of username and position from that interface, and the high-tech values, like let's say he's able to buy some chips or something else like that, right? Or he's able to play some game with faster latency or something. So that time we would have some other functions. And this is a very basic example of low level design of a snake and ladder, and this is asked in a various lot of interviews. So I hope you guys have understood it, and you guys would be practicing it today, so that you don't have to one second. Sorry guys. So that if you are given this problem statement, you would be able to solve it yourself without any help. Can you guys tell me that, okay, someone is saying, should we prioritize any specific data structure or algorithm for managing board position and player turns? Okay, that's up to you. What you can do here is that you can either use a queue, or if you are comfortable with a linked list also, you can use that as well. We want a queue. We are using queue over here. Why? Because we want the person's turn to come after everyone's turn is over. So once his turn is done, we are putting it back at the queue, and his turn will automatically come only after everyone's chance has been completed. That was the reason of using the queue over here. Anyone having any other doubts? Okay, so I hope everyone is clear now. And can I expect, give me a +1, guys. Can I expect you all to solve this problem and push it on your GitHub? It just took me 1 hour to complete, right? It won't take, yeah. What is Karthik asking? Would it be possible for you to share the document with the requirement interfaces, etc.? Yeah. Are you not getting my document after the class is over? I think Harita is uploading to the portal. Yeah, you can speak up, man. I mean, it's not necessary to just post it in chat.
Sure, sure. I'll ask her. I'll ask her once. I'll ask her.
Harita has said that she's posting the PDF of the classes after the class is over to the portal. So if you're not getting it from there, I'll just ask her to post it in the WhatsApp group as well.
Sure. Thank you. Yeah.
And yeah, if you have any doubts, if you want the PDF or anything, you can always ping me. But
Okay.
yeah, thanks for giving me a +1. I am expecting all of you guys to solve this question yourself. You have the requirements clear. This is a very basic game that everyone has almost played in the childhood. So it's also somehow curious for you to actually build something which you have played. You would be able to see how you have learned the previous two classes में solid कैसे learn किया है वो, how you have learned factory class, factory design pattern, and try to have a few more methods. Like I just implemented it in terms of 1 hour problem. What can you do in this case is that try to have a player interface and have a premium player and a normal player. And then if that player is, let's say, let's add Divyansh as a premium player and play it like that. Use the factory method to create a premium player. So I have used entity factory for creating the snake and ladder. Create one more factory. Okay. And I hope, I mean, if anyone is having any doubt, right, just let me know right now. I would explain to you whatever doubts you guys have, or you think if you can add some more requirements or you can add some more functionality to it. It would be very great to discuss it right now. We have the time. And if not, if you guys don't have any doubts, we will just complete one thing which we left it in the previous class. Or you guys comfortable with having like 20 minutes of more extra class right now? Just let me know that.
Yeah, okay, no problem.
Yeah, it's fine for you guys, right? ठीक है. So I'm expecting first of all कि you guys solve this problem today, post your GitHub links and share it with me today or tomorrow until whatever time you are able to do. If you face any kind of problem that time, let me know immediately. You can always ping me in WhatsApp. I am there in the WhatsApp group. You can ping me because this is going to be the starting point for you guys. This is a very basic problem. This did not involve a lot of design patterns. It involved a few of the things, but later when we design something important, you would see that it involves a lot of other design patterns as well. So that time, if you have implemented this, you would be able to see that, okay, I'm not facing any major problems over there. It would be just about understanding what to use at what point of time. Okay. So
Can
please
I
make,
send message on Discord because we are not allowed to send message on WhatsApp?
okay, are you guys not allowed? ठीक है, I am not aware of that Discord group. I'll just ask Harita to add me over there. If you guys are not allowed, I mean, it's not a problem for me. You
Only
can,
admin can send message in that group.
okay, if that is the case, then yeah, you definitely can use the Discord. I would check that thing. Please definitely
Oh.
add whatever inputs you got, whatever problems you faced, and the GitHub link of your Snakes and Ladder game. So when we implement something better in the next class, we can actually discuss what all problems we had, and you would be able to easily jump on to the next problems. Okay.
And also for the screen, like board, I want to use some image. Can I do that?
For the screen board, what is that?
Yeah. That number board.
Yeah, obviously you can use this image. You can use any image you want. There's no problem with that.
Okay.
Okay. ठीक है, if we have around 15-20 minutes of time, let's just go to the class 2 का this thing, decorator design pattern. Okay, I hope everyone is clear with the previous design patterns that we learned. Okay, cool. ठीक है. So what is a decorator design pattern? Now let's come to this. You guys understand what a decoration means? Tell me. It's an English word. What does this decorate mean? Anyone, man, come on. We have so much of time. Everyone has heard this word decorate before.
To make something look good, better.
Obviously. So we would have something before which is not so good. So on top of that, we can add, let's say, some hair, we can add eyes, we can add some nose, something, right? And we decorate it somehow. So let's say we decorate this girl over here. We can add some clothes. I mean, I'm not very good at drawing, but let's say we add some clothes. I hope everyone is able to understand this. We have some uh, rings and all, right? We have just added clothes and all on top of that. Does this change the girl? Or by default, this is a girl, right? After adding clothes and all, it's still a girl. So this is what a decoration means. So for example, we have a very very interesting problem over here, that we have a pizza. What does a pizza have? So here we have said that we are defining an interface pizza, and it says key it will return me the description of it. So we have a method get description, and the second thing we have a cost of it. Now tell me, let's say I want to have a margarita pizza. How would I implement the methods, and do you think I would be able to add cheese on top of this, or let's say tomato on top of this or something, right? So now there is a problem over here. How do I add tomato and cheese and other things? So let's say the margarita is implementing a pizza. So what happens over here is we call the get description method. So here the get description is a abstract method. It does not have a definition. Inside the margarita pizza, when we call the get description, it says it's a margarita pizza. So we tell them, okay, ठीक है, this is a margarita. ठीक है, okay. Now we want to add some cheese on top of this. Again, I want to add some more cheese on top of this, and then I want to add some toppings of tomato, and then I want to add some toppings of paneer. How would I have cheese, tomato, tomato as many times as I want in a pizza class? And if I want to print this, how would my description return me everything that I have added? Implementing it straight away does not give me the access of adding cheese as many times as I want. Okay, so what I have done here is to have a decorator class, an abstract class of pizza decorator. And what does it have? It has a pizza by default. So if I pass a pizza inside it, it will return the same pizza which I used. So if I do pizza dot get description, inside this description, it will take the same pizza, and I can call it as many times as I want inside the cheese decorator, or let's say I have veggie decorator. I can call it as many times as I want. So let's just look at a client code right now. So what happened over here is I created a pizza margarita with a new object. So this is a normal margarita pizza. If I do a get description of it, it will return me that this is a margarita pizza. So if I do margarita.get description, it will return me the description margarita. It will return me the cost of it. Now let us order a pepperoni pizza with extra cheese and vegetables. How would we do it? Can you see that the veggie decorator can take again a cheese decorator, and it again can take a new pepperoni pizza. So what we did over here is, when we defined our decorator class, we can pass on a pizza inside it. And again, it is also calling the decorator of the previous class. So here we can see that even though this new veggie decorator should not have returned me anything, but here, by just having one decorator class, what we were able to do is, we were able to use this new cheese keyword or new veggie keyword. So what I can do over here is, I can add any number of cheese or any number of veggies into it. So what will happen is, if I call new veggie decorator, I can again call new veggie decorator, I can again call new cheese, and from there I can again call new cheese, and it will still be a pizza for me. It will still be a pizza for me, and if I do a description of it, it will return me, okay, this is the veggie, this is the veggie, this is the cheese, this is the cheese. So whatever number of times I have added the veggies into it, it will return me it in the description, and whatever is the cost of that, it will also add the cost of it inside it. So it basically takes the pizza cost plus add $2 for, let's say, veggie, and if it is a cheese, it will have 1.5, it will add 1.5. So by this way, we will call it as many times as we want, and we will also add the cost of it as many times as we want. Plus 2 plus 2. So this is how we can use this decorator class. So did you get the use case of it? Ki where are we going to use this? And how beautifully we have just implemented, or we have used this protected pizza over here, which we are using it inside my decorator class. And now my child classes of cheese decorator or veggie decorator are straight away calling the super class of my pizza.
Hey,
So-
hi, I have a question.
Yeah.
So the cost and get description, they add the, say, in the cheese decorator, we add the description with plus cheese, or in the veggie decorator, we add the vegetables. But this gets added when we call the get description method of veggie decorator.
No, this won't be called at that time. So what we do here is, we have a pepperoni pizza, right?
Yeah.
But what is there inside it? It is a veggie. So pizza pepperoni contains a veggie decorator, a cheese decorator, and a new pepperoni pizza. New pepperoni pizza is a base class. I mean, a base pizza, which is having a cost $8.99, let's say. So what happens here is, when I called the new pepperoni pizza, that time the cost of it returned me 8.99 from here.
Okay.
Cost is equals to 8.99. Now I have a new cheese decorator, so this returned me 8.99. This is clear to you, right? The cost
Yep.
will return 8.99.
Yep.
Now cheese decorator, if I call this cheese decorator, where is my cheese decorator? Here. This thing has a cost. What is
Yep.
the cost? It is having a pizza. What is the pizza inside it?
Pepperoni,
What is the cost of pepperoni?
$8.99.
Now what does this return from here?
Nah, almost 10.49.
8.99 plus 1.5, something like
10.49.
10.49. It is returning some value which is an integer again, 10.49. So what do we get from new cheese decorator ka cost?
Okay, 10.49. Yeah.
10.49. We again pass this 10.49 inside the veggie decorator. Now come here. Veggie decorator mein what is the pizza's cost?
10.49.
And what do we add here?
2.
What is the total cost?
12.49.
So did you see how beautifully we were able to add the cost, and we were able to add as many toppings as we want over here without worrying ki, what have we added? It's just, we just need to call the cheese decorator, veggie decorator as many times as we want. And inside it, we are still having a pizza. So pizza's cost, we got it. And now talking about the description. What is the description of the pizza pepperoni? Let's come back again. Pepperoni pizza. Okay. Hello. Did you
Yeah,
get this?
yeah,
It is
yeah.
pepperoni pizza. So we'll write pepperoni pizza plus it will type what? Extra cheese. Pepperoni, extra cheese. What will again we would write in top of that? This would be returned to veggie. So what would the eventual output be? Pepperoni, extra cheese
Plus
with
vegetable,
extra
vegetable.
veggies, something like that. Extra veggies, vegetables or vegetable, जो भी है. Did you get this?
Yeah, yeah, understood.
We still have all the fields that we were using in the previous pizza ka class, and we added the functionalities on top of this. So it's still a pizza, like I gave you the example of a girl. It's still a girl, but with clothes, but with some hair and etc. All the other things, right?
Yeah, yeah, understood. Thanks.
Okay, got it. Cool. Anyone having any other doubts over here? So yeah, I would be ending the class right now. I think if okay, cool. Divyansh had to go. No worries. Anyone having any other doubts? This is your time. You can ask me. Or if not, if you don't have any doubts right now, you can always ping me and I would make sure that Harita is sharing you the notes of the class after this is ending. I and I'm expecting all of you guys to please add your GitHub links. Please submit the uh, try the problem of snakes and ladder. It's very easy, right? I think most of you have understood this thing. I would be adding my GitHub link as well of the code, but I'm expecting you guys not to see it before implementing it yourself and tell me the challenges that you faced in the Slack group. I mean, in the Discord group or in the next class. We can meet that time as well. Okay, so I think this is mostly it. Thank you guys for staying till now, and I hope you have understood everything. If not, always ping me wherever you want. Cool. Thank you. Bye bye. See you next time. Bye bye.